Welcome to Seen and Solved. I'm your host, Tim Pennington. Today's episode is Getting the Balance Right, Mastering Tin Lead Plating Ratios. We'll explore the critical factors in achieving consistent, high-quality tin lead deposits, the common challenges plating shops face in bath control and maintenance, and how a strong understanding of chemistry and process management can reduce defects, extend your bath lives, and improve production performance. Our guest today is Travis Hilton, an application specialist turned operations manager with hands-on experience in plating chemistry, bath analysis, troubleshooting, and process management. We'll be right back.
This is Molly Kellogg, President and CEO of Hubbard-Hall, and this is our podcast, Seen and Solved. In each episode, we will share practical solutions to complex surface finishing problems. Let's listen in to the latest episode.
So Travis, thank you for joining us today. We appreciate it.
It's my pleasure.
Yeah. Now, you're relatively new to Hubbard-Hall, but I know you've got some experience even on the in the shop side. Tell us a little bit about that.
Yeah. So before I started with Hubbard-Hall, I was a lab manager for a metal finishing shop. We primarily did electroplating, copper plating, gold, silver plating, a lot of the more hands-on plating.
So you know all the pains and aches of working in a shop and what needs to get done to get at the end of the day to get the parts out the door. So that's a good experience to have with this, right? All righty. Let's start with the basics. I like to start with that a little bit. How is tin lead plating bath made? What is important to get right in the very first of the setup?
So tin lead baths are pretty tough in the sense of they're, at least three components, three measurable components. And so typically they used to be made with a fluoroborate-based solution. That's kind of gone by the wayside, and now we're using an MSA, a methane sulfonic acid-based solution. Slightly more environmentally friendly, a little bit tougher to work with.
Why is it tough to work with? Tell me that. Go back to that a little bit. I'm curious.
It's tough to work with because it has a lot thinner margins on either side of what is within the acceptable range.
So you have to be spot on pretty much every day, every minute with this stuff,
exactly.
Right? Where is this being used? What are the benefits of a tin lead application in plating?
So it's typically used in aerospace, medical, military. Those are the main three because it's trying to be phased out of most other applications due to the lead health concerns. And it's a lot of the time used for solderability purposes because it will give you, like I said, much better solderability. It'll give you some corrosion protection, so that'll go on top of copper and steel-based materials to help with that. And it also adds some ductility, which is very important for wire bonding.
So I guess we're talking about a lot of this is electronics, right? Even some of the circuitry board and those type of things. Is that where it's used?
Yeah, that's typically a 60-40 tin lead solution. They have anywhere from 60-40 to 90-10. 60-40 is the most common. As you climb up in the tin concentration, it gets a little bit more corrosion protected, but a little bit less soft and ductile.
You talked about keeping things in spec, which is difficult with a lot of processes, but especially with this. So when the shop gets a bath up and running, how are you testing? How are you making sure the concentrations are right, the tin lead and the acid with that?
So there's three different kinds of tests that you need to do on this. You have to test for the acid concentration, which is a simple acid-based titration. Then you need to check lead concentration, which cannot be done through a titration very easily. And so that's typically done through an AA instrument. And then the tin concentration is an iodine-based titration to determine where the tin concentration is at. From there, you will make adds or cut the bath to get them all within the operating range, which sometimes does not always translate to the targeted percentages on the actual parts.
So when you have that where the analysis looks good, but the deposit ratio is off, what are there still adjustments that can be made with this?
Yes, it's all in current density. Agitation plays a small role, temperature plays a small role, but you can adjust a lot with the current density. You can get it anywhere from 50-50 up to probably 70-30 percentages based solely on the amount of current that you're throwing.
So let's talk about the ratios. The ratios of tin to lead. I know that affects performance of how does it affect the performance of the deposit in terms of, like you mentioned, solderability, durability, those type of things?
That's the main purpose behind it. And so the more lead-rich alloys, when you're pushing 60%, then that is going to be a lower wettability than the tin-rich ones. It'll have a higher melting point, and so it'll have a lot more side of that. It's a lot more ductile as well and soft, so it's good for crimping or anything that needs stress relief. Whereas if you're going to be going more towards the tin side of it, it's going to have much better solderability, but they're a little harder, more wear resistant, and brittle. And the brittle aspects of it are kind of what you need to be careful of when you're pushing up on higher levels of tin.
You spoke to this earlier, but when you talk about the operating conditions, temperature, agitation, the current density, how's that going to play in the consistency? I guess it all has to be pretty much dialed in, right?
It all has to be kind of dialed in because the higher temperature you get, the smoother that it gets, the more dense the deposits. But if it gets too high, then it'll cause the bath to decompose significantly faster and form stannic tin, which is tin 4+, and that is what will eventually cause the downfall of the bath if it's not being handled accordingly.
So, like you said, you want to get everything perfect. Sometimes it's not going to be perfect. Some things go astray. You get some things from day-to-day operations, things move. What common mistakes, contaminants do you see that cause the problems with a tin lead bath?
Yep. So there's the opportunity for organic contamination. That's not something that you typically would like to see in the bath, in which case you most likely need to completely start fresh. However, what's a contaminant that is anticipated to happen is, like I mentioned, the stannic tin, and that is going to show up in the form of debris swirling around in the bath or settling on the bottom of it. And so there is typically two ways to combat this. The first of which is constant filtration, always trying to pull out a little bit. And then even so, you're not going to be able to catch all of it. And that's okay, because when it builds up too much, then you can filter out the entire bath through a filter bag, and then that will kind of get rid of everything, especially after letting it settle to the bottom. And then that way you can kind of skim from the top, hopefully just scoop out all the junk that's formed on the bottom.
Let's take a step back, though. Let's talk preventive maintenance, which is key. I think that prevents a lot of problems that are going to be happening. What preventive maintenance steps should users, facilities take to keep these baths in the good conditions that they should be in, but meeting those very tight specifications?
So a lot of it's very general preventative maintenance, as with most plating baths. And so it'd be turning off or down the temperature when it's not in use, making sure that it's covered when it's not in use, making sure that you aren't overloading the tank with parts, try to keep it within the target ratio of anode to cathode.
That's often forgot. Like I said, preventive maintenance. Do you find that? You find that a lot, that people just aren't really taking a lot of preventive maintenance steps?
I would find that to be the case. Yeah. In most places that I go into, it's people just leave it alone and then wonder why it doesn't last long.
Exactly. Leave it alone is step one in their process. Step two is call somebody. Call you all, I guess, what they would do there. Let's talk about waste treatment disposal. How are shops usually handling that when it comes to the tin lead chemistry?
Generally, it's not treated in-house. Normally, it's shipped out because of the lead components of it. Oftentimes, a lot of the additives have chelators in them, which you also don't want to send through wastewater. And so altogether, it typically is best to send to a third party for treatment.
We always like to talk real life experiences here. Tell us a problem that you've seen and what actually you've seen and how you solved it in the field relating to tin lead ratios. Give us an example of something you've seen lately.
There was a situation of a place that I visited where they were having an extreme buildup of stannic tin, and so the bath, which starts off as a dark, almost opaque color, was very, very bright tan and very, very cloudy in there. And they had tried filtering it. They were replacing filters every day. They were not able to get the concentration down, and so there was a combination of two things that they did that ended up kind of sorting it without needing to make up a brand new bath. The first of which was they added in a stannic tin precipitator, which will cause it all to settle to the bottom of it. It'll kind of accelerate the process a little bit, but it'll kind of get rid of everything that's about to turn into the stannic tin. And then afterwards, they pumped it out of the tank into a drum through a filter, trying to keep the drum pump above the bottom of it to avoid getting all clogged up. And then they were able to clean the tank, do a thorough job, put it all back in afterwards. And then from there, my only preventative maintenance advice for them specifically was to start brushing the anodes, because they were forming a thick black film on them. And then that helped keep them in a much more pristine condition.
I hadn't often thought about that being the toughest part. I guess I've never ran a plating line, so I wouldn't know that was, but it does seem like it's got to be tricky with that. But Travis, thank you for joining us, and I'm sure we'll have you back soon to talk more. Appreciate it.
Awesome. Thank you.
Thank you for joining us. Our goal at Hubbard-Hall is to help you get better results with less chemistry. To hear more stories from the field, go to hubbardhall.com or wherever you stream your podcasts.